Hello everyone. In this video, we're going to look at how to determine the empirical and molecular formulae when you are given a combustion data set. So this set of questions will be slightly different from what we have done for the mass composition because you are involving the production of something from a combustion process. To do that, we're just going to go directly to a problem. So in problem number 1 over here, when you read the question, you can see that the question gives you the mass of the unknown organic compound X and the combustion analysis. When you see the word combustion, that means, I'm just going to write here, is to remember that this process is involving burning, okay, the burning of compound X. So you have compound X, and because this is a combustion process, as what is stated over here, combustion, combust means you are burning, okay? So combust is just another word for you are burning. So X over here is burn in oxygen. So when you want to burn something, you have to burn that in oxygen. And when you burn that, you will be producing carbon dioxide and H2O. So when you have this piece of information, combustion process analysis, we do know that X over here will have 3 things, okay? X will have carbon, it will have hydrogen, and oxygen. How do I know that? Because the question tells me that information. Let's have a look at the question now. So when you look at the question, it says that 0.30 grams of X gave 0.733 grams of carbon dioxide. So you have carbon dioxide right over here. And 0.30 grams of water. So you have water being produced. So when you burn X, this unknown organic X, and then when you want to burn something, you have to involve oxygen. You must have oxygen if you want to burn something. Without oxygen, burning will not going to be happening. Combustion will not going to be happening. Okay, so how do I know? Again, I repeat, how do I know X has carbon, hydrogen, oxygen? From what the question gives to me. It has carbon dioxide, it has water in here. And other thing that the question tells you is the mass of carbon dioxide, which is 0.733 grams, and for the water, 0.30 grams. So you cannot take this, unlike what we have learned in the mass composition. When you see mass over here, and then you're going to be directly put it in here, that is completely incorrect. If you have this kind of question involving combustion data analysis, you cannot take this and you're going to put in here. Some books, they do that, but in matriculation level, we're not going to be accepting that. Okay, so I'm just going to warn you here. If you do like this in exam, CO2, H2O, 0.733, 0.30. If you do like this in exams, this is going to be incorrect. Okay, so do not do this in exams. This is wrong. Okay, so what is the correct way of solving this? So we need to find out what is the mass of carbon hydrogen, and oxygen. For each of the elements, we need to find that out. But the challenge over here is the question does not give you how much carbon is present, how much H, how much O is involved. But you can do that by looking at the information given to you. We have the mass of carbon dioxide and we have the mass of water right here. So what we're going to do now is, one, we're going to find out mass of carbon, okay, by using this number over here. So you're going to use 0.733 grams. Okay, mass of carbon we're going to get from the mass of carbon dioxide. And we're going to take this number. You are going to be multiplying that with 12 over 44. Okay, and why do you need to use this number? I'm going to tell you later. But for now, it's enough for you to remember. If I want to find the mass of carbon, I need to find it from the mass of carbon dioxide. Okay, so you take the mass of carbon dioxide right there because you want to find carbon. Because you can find carbon in here, you can see that there is a carbon. So that's why we can get the mass of carbon from the mass of carbon dioxide. And you're going to multiply that with 12 over 44.0. And when you do that, you would be able to get the mass of carbon equivalent to times 0.733, you get 0.1999 grams. So I'm going to put in here 0.1999 grams. So why can we do this? If I'm going to show you very quickly, why, if you want to find mass of carbon in carbon dioxide, you have to multiply with this number. It's very simple. So now I'm going to show you the reason why. So if you look at carbon dioxide, the molar mass of this is carbon. If you look at your carbon, right over here, carbon is 12 and oxygen is 16. Okay, so you have 12 plus 16 times 2, and that one will give you 44 gram per mole, isn't it? Okay, so you can double check. 16 times 2 plus, okay, you get 44 gram per mole. And inside here also 1 mole carbon exists in 1 mole carbon dioxide, isn't it? If you look in this one whole structure over here, you have 1 carbon. So 44, you're going to write on 44. And carbon just now, if you look at the constant, carbon is 12. Okay? So that's why you have 12 here. So this is the mass of carbon actually. Okay, so that is actually the molar mass of carbon. So this is the reason why we're going to take we're going to take 12 over 44 times with the given mass of carbon dioxide in the question. Okay? And if you look here, back again, you have this. So we're going to do exactly the same with hydrogen. Okay, so step number 2, change that to 2. Step number 2, we're going to find mass of hydrogen. So to find mass of hydrogen, we can find hydrogen in water. So we're going to do the same thing like what we have done for carbon. So we're going to write 0.30 grams. This time, the number that you're going to take is 2.0 over 18.0. And that would give you, okay, would give you 0.00333 grams of hydrogen. So here you get 0.0333 grams of hydrogen. Again, why do we do that? So if this is the reason why we do for carbon to find the mass of carbon in carbon dioxide, it's technically the same as what we're going to do for hydrogen in water. Okay. Again, if we go back to the concept just now, this is actually the molar mass of water. Okay, if we go back to the table over here, hydrogen is 1. As you can see here, hydrogen is 1. And then oxygen is 16. Okay, oxygen is 16 right here. So the molar mass of water is 2 times 1 plus 16, and you get 18. And number 2 on top, that is the molar mass of 2 hydrogen atoms. Okay, why do we need to consider 2? Because when you look in your H2O, 1 mole H2O has 2 mole of H, as you can see over here. So that's why you're going to put 2.0 over 18.0 times with the mass of H2O being produced. So we go back to there. Now what about oxygen? Can we find the mass of oxygen from carbon dioxide and from water by using the same method over here? No, that is going to give you incorrect answer. Why? Because you have oxygen for carbon and oxygen for water. So it's not going to be accurate. But what we can do over here is going to be a bit easier to find the mass of oxygen. What we do now, you're going to take this mass. So that is the mass of the unknown organic X. So this is 0.30. We're going to minus 0.30. So you're going to minus with 0.1999 plus 0.0333 grams. And what did you get? 0.3 0.1999 plus 0.0333. You'll get 0.0668 gram. So you get 0.0668 grams. So that's how you're going to find out the mass for oxygen. So by doing this calculation, you have 1 mark, this one 1 mark, and that is another 1 mark, and you'll get another 1 mark for this. Now, what do we need to do? We need to change the mass into mole, and we have talked about this in the previous video. We're going to use the mole phono concept. Okay, so you have 0.1999 divided by 12, then what is that? 0.1999 divided by 12. You get 0.0167 mole. Is that going to be the smallest? Okay, so the one over here is 0.0333 divided by 1.0. Okay, then you get 0.330. Make that smaller. Okay, so you have 0.0333 divided by the molar mass of hydrogen, 1.0, you get 0.0333 mole, and in this case 0.0668 divided by 16, the molar mass of oxygen, then you'll get 0.0668 divided by 16. So you have 4.175 times 10 to the power of -3. So the smallest number is the oxygen. So the ratio would be, so you have 0. Let me use a different color now. So you have 0.0167 divided by 4.175 times 10 to the power of -3. Okay, so that is going to be 0.0167 divided by 4.175 exponent -3. That is 4. And then 0.0333 divided by 4.175 times 10 to the power of -3. This is going to give you 0.0333 divided by 4.17 exponent -3. You get 7.9. Okay, 7.9, and that one can be rounded off to 8 because it is 0.9. Okay, that is not really clear. So 0.9. So you can round that off into 8. So this one is obviously going to be 4.175 times 10 to the power of -3 divide 4.175 times 10 to the power of -3. You get 1. So the ratio is C4H8O. Okay, C4H8O. You have only one. So you don't have to write number one over here. Okay. So that is for the problem number one. Okay, so now what about problem number two? It's similar to what we have done in problem number one, but this time the question wants you to find the molecular formula as well. You need to find out what is the molecular formula for the organic compound when the MR is given. Okay, you have your MR right here given to you. That means we can find out the molecular formula too. Now, since we have burned the organic compound, again, I would like to repeat that again. I'd like to repeat that if you have the organic compound, and you burn that. Why is it burned? Because you have the word combusted. Okay, you have the word combusted right over here, means you are burning the organic compound. So you can add oxygen and you will be making carbon dioxide and H2O. And according to the questions, I just want to highlight. So this is the mass of the organic compound. And we have the mass of water and mass of the carbon dioxide. So the mass of organic compound is 0.202 grams. The mass of carbon dioxide is 0.361 grams. H2O 0.147 grams. So the first thing we need to do is to find the mass of carbon. How do we do that? Let's say 12 over 44 times with the mass of carbon dioxide, 0.361 grams. So remember this, to find mass of carbon, you're going to take the mass of carbon dioxide times with 12 over 44, just like what we have talked about just now. And this will give you 12 times 0.361, we get 0.09845 grams. So that is the mass for carbon. And number two, we need to find out the mass of hydrogen. Again, you're going to use 2.0 over 18.0 times with the mass of your water, 0.147 grams. And you should be able to get times 0.147, 0.01633 grams. And the mass of oxygen again, we're going to take this 0.2, 0.202 mass of the organic compound minus mass of carbon plus the mass of the hydrogen. And you should be able to get 0.202 minus 0.0985 0.0845 plus 0.01603, you get something 0.08722. Okay, so this is correct. So you're going to take all of the informations here into your Marmora table. So don't forget, because you're going to be producing carbon, hydrogen, oxygen, you're going to write it there. You're just going to fill it in. Then you get something like this. Okay. You get 0.0984, 0.01633. Okay, so you have 0.08727 is similar to what we have got over there. So that should be okay. And then from the mass that you have got, you are going to be converting that into mole, like what I have done over here. Okay, you convert that into mole, convert that into mole, convert that into mole. So if you look carefully, I'm going to make that bigger. As you can see, this is 5.45 times 10 to the power of negative 3. And if I'm going to bring it smaller, if you're going to look here, this is 0.2810 to the power of negative 3. So it's a pretty small number. Between this number and that number, the number of mole of oxygen and number of mole of carbon, which one is smaller, do you think? Exactly. The number of mole of oxygen is smaller than the number of mole of carbon. They have the same exponent value, 10 to the power of negative 3, 10 to the power of negative 3, but 5.45 is smaller than this. This is bigger. Okay, so this is 0.01633. That is smaller number. Okay, it's a smaller number because it has exponential of negative 3. Now, next, we're going to find the ratio. So you're going to divide them with the smallest number. Then you get something like this. So when you look at this one, you have 1.5. So the difference between 1.5 and 2.99, this number can be rounded off to 3. But when you have 1.5 or 1.6 or 1.7 or maybe 1.4, 1.2, 1.3, you cannot round off those numbers. You can only round off 2.9, 3.9, 4.9, 1.1, 2.1. Those numbers can be round off. So what do you need to do? You need to find a number that you can multiply with this to get a round number. And since you have 1.5, you can take this number. You can take this number over here. You're going to times by 2. So when you times 2, you have 3.0. So when you times that by 2, this one needs to be times by 2 as well. So you get 6. Okay. And then this one needs to be multiplied by 2 as well. Then you have 2. So the empirical formula will be C3H6O2. And then you will be able to get 1 mark for this, 1 mark there, 1 mark right here, and 1 mark right there. Also 1 mark for this calculation, 1 and 1. But we're not done yet because we need to find the molecular formula. And I've shown you how to do that already in the previous video, but we're just going to do that again. We have the 148. Okay. So the relative atomic mass is 148 equals to, we're going to have to look again at the empirical formula C3H6O2. We have C3H6O2 and so 148 equals to 3 times 12 plus 6 times 1.0 plus 2 times 16.0 Fn. So what is the number that you can put in there? You have 3 times 12 plus 6 times 1 plus 2 times 16, then you get 74. Okay. And compare with 148, then you have 148 divided by 74, then you get your N. So 148 divided by 74, you have 2. So N equals to 2. Therefore, Therefore, 148 is C3, sorry. The molecular formula is, then the molecular formula is C3H6O2. Remember, N equals to 2, and over there, times 2, you get C6H12O4. 2 times 3 is 4, 2 times 6 is 12, 2 times 3 is 3. So this is the molecular formula. Get 1 mark, and